Welcome to part 5 of our video presentation on chapter 9. In this part we will talk about the implementation phase of the SDLC methodology. Success of the implementation phase is highly dependent upon business manager involvement or support. Naturally, this is the phase where the technical design is over. Also, the system is constructed. So now it's a matter of going live with the system, implementing the system within an organization. So I'm sure any software development project encounters a lot of technical problems as it goes into the implementation phase. But the most severe problems at that phase are business problems, meaning problems related to changing processes, ensuring user commitment to the new system, accommodating user needs, addressing user requirements, addressing the problems that users require, and so forth. So all this requires heavy management involvement. In fact, I would say it requires some organizational power, because this is something that I experienced when I was in charge of an information system within my organization. It was called Digital Measures. It's an information system for capturing and managing data about faculty members within a university. So what I've noticed is that I noticed that because there was a very powerful sponsor behind the system, meaning more specifically the provost, the chief academic officer of the university, was behind the system. It made it easier for me to ensure user acceptance. So whenever somebody was against using the system, they would say, "Oh, I don't have time to enter my data. I don't see what kind of use I can make of the system." At first I would attempt to explain to this particular resistor why it's in his or her best interest to use the system, because it has all those features, and all those features they can save time down the road. But at the end, if nothing works, I would just say, "Look, this is the person behind it. That's his idea. If you have any objections, then talk to him." And usually, just saying that was enough to ensure compliance. So success of key stakeholders in the organization, meaning top managers, is very important. Now, implementation phase typically has the following phases: installation, operations, and maintenance. So we'll talk about each of those steps in a bit more detail. Now, installation phase or step, not phase, step, includes building files and databases, meaning software files and also data files, converting relevant data from one old system to the new one, and also training system users. Now, converting data may be problematic, and data conversion, it's a big sometimes it's a big project on its own. Now, over time, several approaches or strategies or tactics for installation have been developed. One tactic is parallel installation. So basically, an organization operates an old system and the new system in parallel until all the bugs are fixed in the new system, and until the organization feels confident that they can switch to the new system. So it's something that mitigates paralysis, where the old system is abandoned, yet the new system is not reliable enough to replace the old one. Another approach or tactic is pilot. The new system is introduced introduced on a small scale, let's say in one particular area of the organization, let's say in just one department, and this is where all the bugs are fixed. This is where management learns about how the system operates, and what has to be done on the technical and business side to improve the system so that it addresses the needs of the users. And once the pilot succeeds, then the system is implemented in the entire organization. Another approach that seems to be very common, in fact I would say it's the most common, is the phased implementation. So basically one module, one component of the system is implemented at a time. One of my first research projects was PeopleSoft implementation at the University of Houston, and that's exactly what they did. They implemented PeopleSoft at the university module by module. Now guess which module they implemented first? That was finance module, because they were interested in streamlining operations in relation to tuition collection from students. So that was very important for them. So finance module, I believe, was implemented first. And also, this finance module delivered a lot of convenience to students, because before the module was implemented, I think students had to come in person most of the time to pay their tuition. Now with the new system, they could pay online using a credit card. That was a big deal, big improvement in service for the entire university. And then cutover. Old system is totally abandoned at a predefined date, and the new system is implemented, is used at this cutoff date or cutover date. May not be a good approach, because there is something that has been observed, a phenomena that is called performance dip. Performance dip means at this cutover date or cutoff date, the organizational performance goes down, because there's a lot of confusion surrounding the new system. A lot of users simply paralyzed. They don't know what to do, how to use the new system, and this is something that can backfire the person behind this project, because there is a saying that says basically you're as good as your last achievement. So managers, they see that the organization is in complete chaos at this cutover date. And again, if you think about it, it's natural, right? I mean, you cannot just expect that things will work perfectly at this cutover date, because there's inevitably will be some confusion, there will be some errors that need to be fixed. But nevertheless, management may make a decision to pull the plug and abandon this project at this cutover date, or as a result of that transition. Again, this is exactly what happened in the Natural Springs case. Apparently, the CFO did not expect that there will be a dip in performance. There will be some serious problems when they go live with the system, and eventually he got into a situation where everybody was so negative about the new system, so he had to pull the plug. So probably this is not a recommended tactic for implementing a new system, unless you're doing something that is very simple and something that is on a very small scale. Okay, operations. A new application that is operational is referred to as in production mode. So basically it means now it's done, it's just a matter of operating it. And at this point of time, project team is disbanded or disbanded shortly after the system goes into operation. Now, documentation is very important for operations, because what happens is that the system is typically operated not by people who build the system. So that's why they need to have documentation about the system itself, meaning the technical implementation of that system. And also user documentation needs to be developed so that users know how to go through the screens, how to use the system basically. So that's the operation. Maintenance is something that is overlapping and related to operations. So it's basically the process of making changes to a system after it has been put into the operational or production mode. So what are the main goals of maintenance? First of all, correct errors, the kind of errors that were not spotted during the testing phase. Also adapt the system to changes in the business environment. The environment may change. Now, let's say there are new compliance standards, so those standards have to be accommodated. And overall, you can enhance or improve the system beyond the original system requirements. So those are the goals of the maintenance stage. In the past and now, organizations, they spend a substantial portion of their IT budget on maintenance. In the past it was 80%, now it's close to 80%. In other words, organizations spend most of their IT budget maintaining existing systems and not creating new ones. Only a relatively small portion is related to investment into new systems. Most of the funds are related to maintenance. Some of the common problems during the maintenance phase, first of all, documentation is not available, so nobody knows for sure why the system operates in a certain way. Another important problem, changes to one part of the system because of the inherent ignorance of people who operate a system about the entire architecture. So sometimes changes to one part, they cascade, they create a ripple effect, and those changes, they lead to some problems in other areas of the information system. All this is made worse by the fact that programmers generally prefer new development, so people who really know how the system works, who really know the architecture, they are not involved in maintenance. Typically maintenance is done by system administrators, people who are not responsible for the development. So there's always that gap in knowledge or communication that exists. Overall, maintenance can introduce new errors into the system because, again, all components may be interrelated, and when you change one component, it can lead to changes in another component. But however, maintenance needs to be done because sometimes when substantial IT resources are not available to maintain a system, meaning to improve it, to customize it, giving new needs of the business or new characteristic of the environment, then the system will start getting obsolete, meaning the performance of the system is way behind the needs of the organization. And that's, once again, I would like to say that this is something that can be anticipated at the design phase. I mean, you can build your system with anticipation of growth, or on the opposite end, you can build a system that is not scalable, that cannot accommodate future growth. So this is the last step within the SDLC framework, the maintenance step. So that also concludes this part of our video presentation. Thank you for listening.